You know, just for people who, because this is my first time bringing this campus to the Rover.
Oh, okay. Where are you from?
Okay.
Profit, mostly. Oregon.
I like that phone book. It's like you need
Yeah, I have three of these ones.
Okay. Let's see.
Did you say your Girl Scout? No, Ross. Oh, Ross.
Well, I think I'm going to wait till Laura comes back from downstairs. This is a little distressing. There was an email sent saying that it was upstairs in room 307. This is the Mars Rover Celebration Mars Content Workshop. And I'd like to welcome all of you. I guess I would like to have everyone introduce themselves, but if there's the other 8 people we're expecting downstairs, and I am live on Google Hangout. I will someday figure out how to tell people to do that, to log in.
No. No. I'm only doing Mars 2 or 3 times a week. Unless, no, that's what I'm saying. But when you're doing I think she did it. Oh. It was only a couple of us. This would be. So I don't think this week. Yeah, this week is okay. One second. Something like this. Good morning.
Morning. Come in, sit down at,
Are you looking for more friends?
Yes.
this is the
Yes.
place.
You made it. Yeah, we made it. We're like,
Yeah,
where's
that's
everybody? We went around, up and down.
I'm gonna let you do it.
Well, we're hoping a few more people show up.
Why not? I saw a lot of people trying to park. Because there was like, the game thing. I didn't know about all this. Didn't let us park this anywhere.
Okay, I haven't paid yet, so.
Wait for Laura to come.
Oh, okay.
She's handling that.
Okay, good.
Check should be payable to Physics Department, University of Houston.
Well, but some of them. I had to finish it.
Bye now.
I think I put the sign up just in time for when they got here. Because I saw you guys walking to the elevator. I was like, okay, this one's it's well marked. Thank you very much. I thought of that this morning, and then we were knee deep in.
Did you guys
Why
get,
didn't
did
you
you guys get an
myself?
email? Did you get an email saying that it was real?
No. Well, I don't know.
I didn't
I
get
left
any.
my phone at home.
Only one of the people
I
at
sent-
our school got it.
Really?
Yeah.
I sent it to
See, I
Laura is the person you pay.
You sent it when?
Thursday.
Oh, no, I didn't.
yeah, I never got that. That's just religious.
Send it straight from them.
Well,
I didn't even do mail merge. I
We didn't get it when she did.
I got it Friday morning. Because I sent you yours individually.
Laura,
Okay, well, the other one didn't.
Yes, sir.
I thought you must have sent out two because there were only 4 names on the one I got.
No, I did. I sent out more than, because
Okay.
I sent it out several times. Because I was having to cut and paste the addresses in.
That's good to know that people aren't getting your emails.
Yeah, that's disconcerting. Yeah.
Mine came.
Right, and you were in the same, yeah. That's why I was like, that'll be the barometer of tests. And I sent one to myself, too.
Yours.
Okay, so I think we ought to get going, whether people are here or not. All right, a whole bunch of people have, well, first off, let me welcome everybody. You can read. I'm Edgar Bering, and I guess we have one person still in the ladies' room. I'd like to go around the room and have everybody introduce themselves.
I'm Laura Jacobs, and I work with the Teach Houston program, which is the program that certifies secondary math and science teachers. And I'm also a partner in crime with Rover.
And a crime it is.
In crime.
I'm Sue LaCousy at St. Francis de Sales School, and our 3rd grade has been doing, I think this is I'm glad it's still on here.
I'm Linda Shainfeld, fifth grade teacher. This is my second year.
I'm Richard Embrick. This is my first time here for the Rover, and I am the robotics and engineering instructor for sixth graders and project lead delay instructor for seventh.
Yay, project leader. My name is Rhonda Wilson. I'm just trying to text my coworker because he's trying to figure out where we are.
Yeah.
And that was me that called you.
Was it? Okay.
Okay.
We're able to get right through the barriers that teenage changes.
Yeah, Laura, if people didn't get that email, a lot of them are probably just going to be frustrated and go
Well,
home.
what I'm going to do is I'm going to call. I have all their phone numbers.
Okay.
So there's phone numbers. I'll call who isn't here and find out what assistance.
Okay,
I
and
first learned about the Mars Rover project or challenge last year. My coworker and I were involved with U of H Sept program, so we were asked to judge one of the, a couple of the projects. So I thought it was interesting, and I don't think Alvin has done. I'm in the Alvin School District. I teach fifth grade science and math, and I don't think we've done that. We haven't been involved. I don't think. So I thought this would be great for us to do.
Cyber Chapman coming from KBIC. Just learned about this a few weeks ago. It was sent to us, an instructional coach in Math and Science Elementary, and I don't think we heard of it before.
okay, yeah, I should. Laura's going to call people, I guess.
She just called me.
Well, I'm Edgar Bering, and in the context of Mars Rover, I'm actually a soccer parent run amok, because my children had this program in fourth grade in 1999 and 2001. Really? They are now adults who are both.
There's no sign, just come in.
Just come in.
I'm sorry, this is Morse Road.
Yes.
Been here for we're looking for this place. I'm so sorry.
Well, somehow all the emails that gave you the room number that were sent out Thursday never arrived. Help yourself to some breakfast. I'm not, with this small crowd, wandering around isn't going to bother me. Well, tell us your name now that you're here.
I'm sorry, Kelly Bose.
No, we sent out a room change email on Thursday, and if you didn't get, along with how to avoid the road blockage, and if you didn't get that email, then
I had the road blockage information too.
yeah, a map of how to go around it. Okay, so I'm Edgar Bering, and the Mars Rover curriculum is something my kids did in fourth grade. That's me. Now, this is the author list of this presentation. Now, this is last year's list. It has Elena is coming, I think, but I haven't seen her yet. Maybe she's one of the people who's lost. All right. I'm really not going to talk much about the event per se today, because that's next week. What we have discovered over the years is that many of you are. Laura, do you need to take roll so you can find out who's here?
Okay. You're gonna be on the list from the Senate. Okay, and Lydia.
Linda and Sue.
Oh, Linda, sorry, Linda. Okay, so. Linda. Okay, yeah.
Like a good instructor, the other reason for this pause is so you can write all this down.
And you are Richard, right?
Yes.
Okay, cool.
And I'm Boromir.
And you're Boromir, of Lord of the Rings.
Yeah, I mean, we have to have a dummy identity to sign in. So I sign in as Boromir Voronwe, from, of course, Middle Earth Middle. Somebody somewhere has to have started that school. You know, it's just too good a name. Probably in New Zealand. Anyway, I really want to thank my many co-authors, particularly Walter, Stephanie, Christine, these people that work at the Lunar and Planetary Institute in they work at the Lunar and Planetary Institute down in Clear Lake, and they provided many of these slides.
Wait for that.
Oh, I had that up for quite a while. So I was saying I have discovered that, well, it's relatively easy to teach how to teach our curriculum. A lot of you aren't terribly knowledgeable about Mars, about planetary science, and stuff like that. Now, by way of advertising, this past summer, got invited to give a 90-minute public presentation on what's up with the planets anyway. Actually, that isn't my real title, but that's. And so I actually have a carefully prepared all the latest and greatest information from the planets that is aimed at the general public. So if any of you need a presentation, please don't hesitate to get a hold of me, because it's no real inconvenience now that it exists. In fact, I'd rather like to give it many times. I put quite a bit of work into the presentation. Are we good?
Yes.
I guess I should have said that it's actually in your hand. That page is actually in your handouts, but we're not crazy. So very briefly, what are we really going to talk about next week? And we have, as you can tell, plenty of room. So if you decide you wanted to come next week and you didn't sign up, first off, we'll let you come for just $15, not another $25, and there's plenty of room. Basically, this is a curriculum. It's a full curriculum, 5E, NASA approved, full 6-week block of 45-minute periods is covered by the curriculum. It's thoroughly TEKS aligned with current TEKS. And it is also NGSS aligned. And since Common Core really doesn't touch on science, it's not particularly Common Core aligned. The thing we have done that's unique and particularly interesting is the teams are selecting a specific science mission on Mars, and I just realized I forgot to do something. I need to stop very briefly, go over to my Hangout, and share my screen. Okay, so I am now sharing my screen, and I can go back to my PowerPoint. Control, come on. Okay. the heart of Mars Rover is the idea that the teams begin by researching Mars. So you get to teach a lot of research skills. And it's easy to teach them research skills about researching Mars because there are three things that really fascinate kids and get them really excited about science and engineering. Airplanes, spacecraft, and dinosaurs. And this covers airplanes and spacecraft. We're working on the dinosaurs part. That was a joke for my exobiology friends. We have the magic. And so our motivation here is to get kids excited about science by starting with something that excites them. Mars, spacecraft. And if they really have the bug and are doomed to be an engineer, blowing things up. Hi. Oh, there's Elena. Hi.
Hi, I'm here.
Maybe you guys should huddle together for warmth. This will work better in groups, but so as I was saying, the kids start by researching Mars and learning a bunch of research skills in the process, and there's a whole lot of TEKS and science curriculum learning objectives that you can cover on Mars just as well as on the Earth. I mean, erosion happens on Mars, and if you're studying erosion, you can study it on Mars. Once the teams select a specific science mission, then what? What they have to do, I'm speaking about the slides, not to them quite so, but what they have to do is design a mission to answer their question. Now, this is very exciting, partly because, first off, the fact that they picked the question is incredibly motivating. You know, you're in middle school, late middle school, most kids, before you really get to choose courses of your choice. And even within those courses, you don't get to pick what you're going to study. But here's a way to actually engage the kids in selecting what they're going to study in a way that still addresses a whole bunch of specific learning objectives set out in the TEKS or in other curriculum standards. So once they pick the question, then they have to figure out how to answer it. Then they have to design and then mock up a spacecraft to answer it. I should say that since they have to go through space to get there, surface rovers are considered spacecraft. This conforms to recent research instructional paradigms in a way that science fair doesn't, because first off, they're beginning with a question, not a hypothesis. A real improvement. And they're working in teams like everyone in the real world does. And also, we've managed to structure this, and I don't know quite where the magic was, but this program doesn't end up being hag-ridden with helicopter parents. The kids really have to do this themselves. I think it may be the skit in which they have, and the documents in which they have to document what each kid did. But we see very little parent work in this. Those of you who've done this before, I see familiar faces. You're nodding at me, so you know what I'm talking about. All right, so this is we're going to do the basics of Mars science, and we're going to get there very shortly today. And Elena, somehow your name is still on the certificate, so at some point take a break and sign them all, would you?
Sure.
Okay. We do have 6 hours of credit, and your name, we do send your name through our elephantine bureaucracy to the TEA. We have a capstone event. Now, signing up for this workshop does not sign you up for the capstone event. You got to sign up separately. We always have somebody who misses that point, but we have good news. Remember, last year we were in the hotel? Not quite optimal. We are back in the University Center, in the Houston room. It's been remodeled. It's all nice and purty and clean. And not only that, but the University Center has its own big theater for the awards presentation. So crowd management and moving people around is going to be easier. We still are going to have most of the science tour activities, at least for middle school, maybe not for elementary school, over in this part of the campus. Key point here, when you enter, the deposit is one deposit per school, but each teacher has to enter separately. You get 3 models per teacher. If a teacher is handling more than one classroom, you need to sort of send me an email, and I will up your model allocation. Because our nominal entry size is 3 models per classroom. And I get emails every year from people, well, I have more kids than that working on it. Yes, you have to have a cut-down capstone at your school. A down-select capstone is the correct term. We will have NASA speakers. I think we're going to have Erin Beisner, who's a really awesome speaker. She has, among other things, she's an international Taekwondo champion. Don't make Erin mad. Probably also again have Bonnie Dunbar. Okay, so we're looking forward. Oh, what was I going to say? Please, we have for the last N, where N is a number approaching a single hand, been sold out. But we don't sell out on day of because we have no shows. The thing I would urge is, particularly if you decide before November 15th that you're going to not be there, let me know and withdraw your entry. Because last year, I had one guy who entered quite early, and in the middle of January, I suddenly got this very, very ugly, using expletives email from him saying, you know, the intent was, would you please kindly take me off your mailing list? But you can imagine that said with, you know, in the tone of an axe murderer running at you. And I'm going, dude, you entered. What's your problem? You entered and didn't withdraw. So why are you so angry? If you want me to stop sending you emails because you have decided not to participate, just tell me nicely at the time you make that decision. I really need. I have a waiting list in mid-November. So if you aren't coming, tell me, because there are other schools that want to be there. And the same is true on the individual model level. If you're only bringing one model, And I'm holding 3 for you. That means there are 3 physical tables in the room reserved for you. And if you're only going to bring 1, please tell me, because there are other schools that are just dying to send more models. Yeah?
Quick question on that. I'm from one of those schools. So I have sponsors, science teachers, math teachers that will be going with us.
Mm-hmm.
Can I sign them up for the models for their groups, or is it just 3 models per school? Period?
It's 3 models per teacher per classroom.
Perfect.
So if you have well, there is a limit.
Right.
Anybody here from Quail Valley? Quail Valley requires the whole school to participate. Now, if I actually use the 3 models per classroom, they'd get 39 models. We arm wrestle over that. Last year they sent 10. They had a really big whoop-de-doo down-selective campus championship event and then sent 10. So, yeah, if you're going to have, if I am sufficiently silver-tongued and persuasive that you do what Quail Valley does and have the whole school do the whole curriculum as a full 6-week module, then we'll have to talk, because somehow 2 or 3 schools each with 39 models isn't going to work as well as we'd like. So, but
And we're going to follow this curriculum because I have an actual class, and then have the teachers with math and science.
okay, the good news, by the way, is that what's up there now, and I put it up on Monday, is what's up there now is the output of having been reviewed for 2 years by NASA reviewers, your input, and so on and so forth. And by the way, those of you who were there last year and haven't filled in the survey we've been emailing you about, we need those today. And if you, do you have them, Laura? Are they
I can print them out, or they could do it
online?
late, so.
I thought Ken was going to show up with
During
some.
the break, we can talk about it.
You might tag up with Ken, because I thought he was going to be here with some. But we have a drawing of all the people who send in their stuff. If you're looking for Mars Rover, this is it. So we have for the people who were here last year and have not filled in your survey, we really need it. We really need it. And to incentivize you, we have a raffle of all the people who actually turn it in to give to. And the raffle is for 2 things: a $100 gift certificate to, what's the name of the store, Laura?
Teacher Heaven.
And
And
drum roll, please. An iPad Mini. So spending 10 minutes to fill in the survey about your experiences last year, right now your chances of getting, right now the turn-in rate is so low, it's fully justified the gamble of that much time, because your chances of getting one are high.
good odds.
All right. Time for handouts. We're at the new
Those handouts.
those handouts.
Those handouts.
Okay.
Those handouts.
Now, I don't know if any of you have set this up as an outreach event with your students or not. When the people in the Maven outreach team hope you have. But you can teach about it on Monday, because it will still be ongoing. The latest American spacecraft to go to Mars, a mission called Maven, which is researching the historical escape of the Martian atmosphere by way of understanding its current escape rate is entering Mars orbit tomorrow night at 8:50 p.m. Central Daylight Time. It will be broadcast live on NASA TV. I was actually hoping that my colleague Erin Wood, who has actually taught Mars Rover on occasion in the Boulder area, would have done more. She has quite a lot of teacher materials, but they're sort of long-term teacher materials. She has a competitor curriculum to our curriculum, which can be found. This isn't about competition. Can be found here on this website. And if you think this looks, the spacecraft configuration of the solar panels looks kind of funny, it's gull-winged because this aero brakes and it does deep dives. It has quite a lot of extra fuel to boost it back up after it does deep dives, but it's going to do deep dives into the Martian atmosphere for about 70 of its orbits. This is what will happen tomorrow. Ignition on the main burn is here, and that will be pretty much spot on 8:50 p.m. Central Daylight Time. It will burn for 33 minutes, and then it's going to enter a 35-hour basically commissioning orbit, because for the next 2 weeks they're going to turn all the instruments one at a time and check them and make sure everything's still working. Then they're going to lower the orbit to a 4.5-hour science orbit that's actually has an Apple Mars about there. And it's a nominal 1 Earth year mission, but I'm sure they would want to run longer than that. But the nominal mission times are always set so you can do the base primary science. What's the minimum time needed to do the primary science? This is the events timeline, and we just handed that out so you don't have to copy it all down quickly. And so here it is. For those of you who work in Greenwich Mean Time, UT, my colleagues at Texas who don't do geosciences and don't do actual real-time science where they have to time things so other people always wonder, what are you talking about when you show a graph with an axis that says UT? I actually did that at a talk I was giving at UT, and they're all going, wait, what's the axis? And I said, universal time. Oh. So the burn is actually scheduled. That's 1:50 a.m. UT is 8:50 here, 5-hour difference. And the burn completion is a little uncertain. That's going to depend on the efficacy of the thrust and what the nav computer on board tells it to do. And they'll get high gain radio signal back at about 10 p.m. This is in Eastern time, by the way. So this is 10 p.m. our time, and by maybe 11 p.m., NASA TV will be able to tell you pretty much how things came out. Let me I'm actually want to show you something here. This is actually running partly on my computer. This is the NASA EYES homepage. And what I'm going to show you briefly is eyes on the solar system. If you Google eyes on the solar system, you'll get to and eyes on the solar system is the one that is the most mature. And hopefully this is going to do something sensible, like actually start. Um, why? This is the one I didn't turn on yesterday. It has worked for me many times in the past. I am not sure why it is not coming up right now, but I will try going back to it. When we have break, I'll see if I can get it up. Anyway, that's NASA's PC Planetarium program, Eyes on the Solar System. It's really quite awesome. So what do we do in our Mars curriculum unit? And it's not necessarily in this order, but we research Mars. The kids first have to pick their own question. And here's the key feature. They decide on the mission, and then why is this so important? What they're doing is they're learning how to plan a scientific investigation. They have a question. How do you answer it? What measurements do you make to answer it? That is the heart of our curriculum. And it was an extraordinarily difficult set of lessons to read. They're sort of right in the middle of the curriculum. Lesson 5, pick the question. Lesson 6, 7, and 8, okay, how do we answer this question? Teaching somebody the intellectual process whereby they decide what it is they have to learn to answer a question is very challenging. And to be honest, I've had students, graduate students, who mastered all their core courses in physics, spent 2 years taking graduate physics courses, and then they were a couple of years into their dissertation, and then they had to defend their plan. What is my question and how am I going to answer it? And it turned out that, and this has happened to me twice, I've had kids, well, these are adults, who couldn't do it. They could not construct a strategy for answering their question. And after, they flunked out of graduate school, basically, because they ran into that barrier in their skill set. So one of the things we're going to try and do is make sure that people have, this is the real heart of critical thinking, is plotting a scheme to answer a question. So that's what we teach. Okay. Now, one of the issues that comes up, you have on your table pony beads. So what you want to do, this is an activity. It's activity time. You've got stuff on your table. You have pony beads and yarn, and this is actually our 3-4 activity about how big is the solar system. So this comes out of our first lesson in our curriculum. Get together in a team. We have enough. We have 9 people. With 3 teams of 3 will work. So you may want to circle the wagons in 3 teams of 3. And you've got 5 meters of yarn. So and we have more yarn somewhere. Tie the sun bead, and you get to assign the beads. You have your 9 beads or 9 beads, one for the sun, one for 8 planets. Using the table in your handout, measure out the distances to each of the planets from the sun, and then work together to actually do the beads on the yarn. So please gather together in groups of 3 and get started. We will have about 20 minutes or so on this activity.
He was the brave man who sat in the front too. You know.
I prefer to sit in the front. So
Yeah, me too.
The handout is there.
Yeah, I'm just trying to locate where it is. We got so much goodies in here.
Some table.
Oh, I'm sorry.
Okay, so I decided to
Hello? I'm fine. We're in 307. We discovered emails were sent out to everybody on Thursday, and most of them didn't arrive, which is sort of unfortunate. But we're upstairs in 307. Right. We're in 307 in Farish. Now it's fine. Okay. All right. Bye. That was Ken.
I was going to say that was Ken.
He did not get the room change information.
Did he get the The email? I'm gonna look at my sent folder. I don't get it. Okay. So you all found where this is in the monster packet. It's in the packet that, is this on the front? And it's this far back. So it says lesson one, overview of the solution.
Do you teach it?
Yes, yes.
Well, that would probably.
So we have.
I think you're supposed to, it's like, that is 5 meters. And so, yeah, I think you have to, if you look at, you know, how many,
Well, we're supposed to use 3 meters.
300 centimeters. This is.
5 meters. 5 meters.
so like that's how long, if we look at the order of, and that's space between there.
Although we do have one mark right there. This is going to be the. This is kid all the
Welcome to Eyes on the
I'll get
Stairs.
everybody else.
Where you can just go to the planets and the spacecraft exploring. You can enjoy your interplanetary backyard like never before. Click and drag to have a look around, or use the buttons below to get started.
And now that I'm supposed to come in, because they can't.
Well, like
Where are we at?
You know what chances are, none of us will be doing this.
we can always stretch it. Make it 7 from the sun or 7.
So what I do is,
Oh, but I have.
At least you can see the important parts. It's probably good that you have this header because the top part that's cut off doesn't have anything on it.
Actually, it's the bottom that we work so hard on. That's cool.
Murphy rules us. Murphy's Law.
And you can tell I am actually using the high-res version.
Are you?
It,
But see, look at the. Well, I guess it is. I don't know. The one I have. Maybe it's because it's small.
no, but over here, it's still not.
Right. Got it. On the bottom.
I actually should have said, yes, do you want to upload the new version?
Of.
Eyes on the solar system.
Oh.
Okay,
Is that why it wasn't going for you?
Yeah,
Oh,
yeah.
Cool.
Okay, I'm going to start it again.
See what happens.
So let them see it.
All right. Only out of 11 people, we have 9. That's a pretty good turnout, actually. So.
Well, I was also expecting Nina.
Well, yeah, and I emailed her individually. Like I typed in her. I mean, I know it went. I'm gonna look at my sent box.
Oh, I like that. I like that.
300, that's going to be Saturn.
Now, the reason for this activity, and I can see some of you are working on it pretty hard, one of the things we're doing in the Mars Rover curriculum is using research into what's most poorly understood by kids to select the activities and the things we emphasize. And kids have no clue how big the solar system is. If you ask a third grader in Houston, or which is closer, the sun or Los Angeles, you're likely to get the answer the sun. They can see the sun. Saying I'm very deaf.
Oh, in tape.
The tape. All our supplies general supplies are in the back, and when Laura comes back from wherever she is, this is her office across the hall. So if we don't have it here, she can bring it in the heartbeat as soon as she gets back.
Is that what it is? That's why, like, Thomas, he doesn't take no for an answer. Because they were started robotics. So this is lesson 1 way in the back. Using what you learned, bro. Your kids would be like, really? This is what you want to say. I know.
Oh, really? Well, yes, I understand. I wouldn't say I'm you bring more people. Yes. Yes, I was
I used to
it's a
we used to, yeah, but I went to the science. I don't know if you're in science. Yeah, we adopted fusion. And I went to the past. I don't know if you went past. Fusion was because it's not, it allows to which a lot of our teachers do stuff. And they can do, do things at home, and it's not only textbook, it's also computers, like online based. And if you have Sept, it's in their language. Yeah, so they can go on a computer and everything. And I like Central Music, but usually I like better. For technology.
Laura, there was a call for Scotch tape.
Yeah, I was using it. They give you a lot of stuff. I use it as supplement. I always tell teachers there's a supplement. Is it more of a skill set that they don't have? Nervous about?
Yeah, we have that.
We have our staff here.
Yeah.
I'll think about how to do it.
That's awesome. And that's the biggest problem. Or science is so they still see because my brother just got started this school.
Want to take
Oh,
There you go. Right here on your chair.
I just have 12 kids.
It's like you're not so heavy focused on math. Like my God, it's cool. That actually is a good one. That means you almost everything. Six tests.
And that's how it is now.
Yeah, because we do it, we like to do it. We go, we.
This is middle school.
All right. Are people getting close to done here?
We're done. We're done.
Oh, okay. Well, let's. I don't think I'm going to do the. So now at this point, when you're working with your kids, you would just have them discuss their results with each other. I could hear you were all discussing them, although it sounded like discussion of the Astros. Now, some of the questions that you might want to pose to your kids, and this one, particularly in elementary school, is really fun to get them to actually demonstrate. I think we put that in one of the lesson plans that they should demonstrate. What is the difference between rotation and revolution? Okay. Well, planets have two motions. One is to... Oh.
You need any help, Dr. Barry?
We should have probably handed these out.
Hold the sign.
Although we want to keep these, don't we? But
Some of it's for the next, no, it is for
this,
just today.
yeah.
Okay.
Here's the piece of your activity that we didn't give you the cards. You're supposed to actually label the planets along your string. So what you would do if you were teaching this in class, you would have the students stand up with their string and stand next to it, one kid each. You do this in groups of 9. Maybe one of you can volunteer a string and you can all do this. Actually stand there with their labels next to the string.
5 cards and I'll just hold back this.
Well, there are 9 of you. If you collaborate on this,
No, it's just that our position. So what you were supposed to have done, and I think these guys actually did it looking down at the floor, is scale it properly.
The very first planets, the inner planets are all close together.
The inner planets are all close together, and basically you have flashing the cards. The cards are bigger than the separation. So teaching this in a class, your activity would be to, at this point, do what these guys have done. Spread this out on the floor spread it out across the room, and then have one kid stand next to each bead holding the relevant label. The other thing you would do at this point is get them to demonstrate rotating and revolving. A planet rotates about its axis and revolves around the sun. So, and if you have one of those classrooms with a nice big open space, or you can set it up so that the kids can, we can almost do it in here. You can walk around. I'm going to fall down if I do it, but if you're 8 years old, this is really fun. You can have them model the difference. And so I should have had those out earlier. I'm sensing a certain amount of, we're adults here, resistance to all standing up and movement.
It's Saturday, you know.
Okay, now, in the middle school version of this, and we do something a little different. The first thing we do is work out, and this is not quite the right size beach ball. I wanted this size. Yeah, at this time of year, finding beach balls in Target is hard.
I did look at one. They didn't have it.
Anyway, so if you're going to do this, you have to kind of think ahead and shop for your beach balls in May, when the stores have lots of them. But you want about a 2-foot beach ball. Okay. Now, assuming that I have a 2-foot beach ball, in the middle school lesson 1 lesson plan, the kids are asked to do proportionality and work out which of these various spheres are the right size for the various planets. I need 2 6-millimeter beads. I need 2 of those beads. Okay, so when you do that, and you start with a 2-foot beach ball, 60-centimeter beach ball, you discover that the way the proportionalities work, I'm not sure. Okay, the numbers come out, and I will read them. Maybe I'll just put this up so you can see it. Okay. All right, so you ask the students, and this is the middle school lesson, calculate a scale factor. Once you've got the correct scale factor, then you can calculate the size of Mercury. So Mercury comes out, I'm going to put them all here next to the beach ball. So there's Mercury. And I'm not putting them to scale at this point. Mercury is actually further away than that. It turns out that the Earth and Venus both come out. I'm not sure that helps.
Doesn't matter. Okay. All right.
The Earth and Venus come out to be 6-millimeter spheres. And we've had to put in the lesson plan that they are 6-millimeter ball bearings. That's because culture. What are we actually talking about here? BBs. But
you can't say BBs because it's wet.
You can't say BBs, and these are actually 6-millimeter beads.
These are beads, see?
Now,
I know, right?
okay.
The boys probably would.
This is my cinnamon imperial. No.
Yes.
Okay, then this is I'm being defeated here by a change in brand specification. Historically, Red Hots, the Red Hot candies, were almost exactly 2.8 millimeters in diameter.
So they've made them bigger now.
These are much bigger. That's probably why we put down Cinnamon Imperials. You want a 2.8 millimeter diameter candy. So I will use a cake sprinkle. Cake sprinkle is a little bit on the small side, but the current version of Red Hots.
These are all.
I didn't get that sprinkle out.
They're so tiny now.
I just
Here,
can't.
give me.
Okay, so this here Cinnamon Imperial was supposed to be about 2.8 millimeters in diameter. You might need to edit that.
I'll find something that's the right size.
She didn't want to include Red Hots because it was a brand name.
It's a brand name.
Yeah.
This is a Red Hot, and
That
it's
is
much
Red
bigger
Hot.
than they used to be.
That's what's available. They're bigger than they used to be. I think is what we figured out.
They've changed their size.
He just ate. What was it? Which one is 2.8? Mercury? Mars? You just ate Mars.
No, I ate the faux Mars. Okay,
Come on.
Jupiter is this kind of puppy. Saturn, ping pong ball. And now these guys, I need two of these.
Okay.
These guys are a little on the small side because actually somehow, honestly, this is the size of Neptune and Uranus, about 1 inch. Saturn is more like 2 inches, and
One with different color.
no, that's okay.
Doesn't matter.
For reference, if we actually look at the numbers, this is what we need for Uranus and Neptune. And Saturn is 2 inches,
Okay.
and Jupiter is 6 centimeters, is a skosh bigger than 2 inches.
I see a trip to Hobby Lobby in my future and standing in the beat aisle looking at all the different dimensions. Because that's where we could get them all. And then
Actually-
you can keep them from year to year. We should bring them for you guys. Maybe we'll do that.
These guys really roll,
Well, we can put some tape down.
so that's okay. Anyway, now, if you actually wanted to do this model to scale, now if I actually had a 60 centimeter beach ball, you take a piece of twine and wrap it around 32 times. I think I said 32 times.
64, yeah, 34 times. So that's it.
34 times. 34 solar perimeters is equal to 1 astronomical unit, which is 150 million miles, 150 million kilometers. That turns out to be enormous. If you actually had a 2-foot beach ball, and one of the great things about the fact that, well, my son who went to college in Canada refers to it as hand egg. We'll let you figure out what the reference really is.
Welcome to my world.
A hand egg field with the 10-meter markers and all that.
Got it. And I've heard that one.
Out handy to the school, and that's the good thing most of you do.
Right.
You go outside and you unwrap 32 wraps around a 60 centimeter beach ball. It's 64 meters. I mean, You're more than halfway down the football field, and at the end of this, and this really is illustrative. So you've got this 2 meter beach, this 2 foot beach ball. At the end of the tape, you have this puppy, a 6 millimeter ball bearing or plastic bead. Is that really 6 millimeters? Wow.
It is. I read the time frame on
That really gives the kids some idea of the scale of the solar system. Because, you know, you're 50, even if you just approximate it, you don't have to wrap the string if you know the numbers, but wrapping the string gives them an activity. If you wanted to do Mars, this cinnamon imperial would be slightly the old style cinnamon imperial. A 2.8 millimeter diameter sphere would be, it's about twice that far. The actual number is you wrap it around 52 times, and that's nearly to the end zone from the other end zone. If you actually wanted to do Neptune, you need a big school. This is about 2.5 kilometers away. Now, if you happen to teach near the UC Boulder, where they actually have a scale model of the solar system, goes all the way across campus. They take the 2.4 kilometers. It's a big campus, and they have a model of the sun yay big. And on the other side of campus, there's this ball this big on a pedestal. Says this is Neptune, with pedestals all the way along on the right places. Some of the agricultural high schools in rural districts that actually have a farm on campus actually might have 2.5 kilometers of space. My school did, because the school was a farm, had been somebody's fairly large farm, and the whole farm was given to make the school. But most schools don't have 2.5 kilometers. I know that if you started from my kids' elementary school, which was Frostwood, you'd be in the middle of Memorial City. Maybe we don't want to do that. Okay. That covers this activity. I'd like to introduce a visitor. Not a visitor, he's a member of our team. Ken Neeser. Ken, take it away.
Okay. Good morning, guys. I work for another part of the University of Houston Times, and we work on the evaluation of the Mars Rover program. One of the things we're doing, based on the curriculum that was written last year, is we are interested in getting feedback from the teachers who participated and used the curriculum last year. How many of you did participate last year and used our lesson plans? Did any of you guys participate in the online survey? What's your name, man?
I think it is. Is it Rover?
Well, I don't have you in the system. I don't have you as having completed it. Would you mind?
No, I don't know.
Would you mind doing it?
Yeah. Elena's been with us for several years. She might have done it the year before.
Yeah, it might have been the year before. Okay. And if you wouldn't mind filling these out, we'd be really appreciative to get your feedback on that. And one thing we have done, we did send out email reminders with a link to the website where there's an online version of this, but apparently we're thinking there's a lot of spam filters that are keeping those from getting through to teachers. And they had to go, you know, I know you sent out reminders, but they had to go, the email had to be sent out through the system in order for it to be valid, so Colleen did that last week. And You did get this?
But you won't need more, I mean, it's.
Yeah, if you would go ahead and complete it here, and I'll include you guys in the drawing, yes.
And there may be firewall issues too.
It could be, since it's sent from, like a Survey Monkey-like site, I think that's one of the big issues we're having. District spam filters and
actually put individual emails into the.
Yeah, Colleen tested those, and I didn't see the full thing.
Coming from her email.
I'm sorry?
But she sent it from her email?
She sent it from her account on the website.
Oh, okay, so I sent it from my ear.
Yeah,
So,
But we've sent emails containing your request and the links out separately.
right.
And
yeah, Colleen was saying that those links unfortunately don't get them into the survey site. She had to do it, because each one has a unique ID to get in for their own survey.
oh, so the emails that Laura's been sending out haven't had the actual.
They won't allow teachers physically into their survey. Yeah,
Okay, we need to work on that for next year.
definitely have to work on that for next year.
Because when we send out broadcasts with incentives, the
We couldn't figure out why the judgment stayed so low after we put the incentive in. Now we know.
oh, okay,
Mystery solved.
yeah. So the emails have to come from the survey site sent by Colleen.
Yeah, we may have to.
It might help for next year if you empowered Laura to do that too.
That's a great suggestion.
We'll talk.
Yeah, I'll talk with her offline.
Yeah.
Okay. Well, we've been at this for an hour and a half, and so I think this is a good moment for what we would term human element range extension. So if you want to take about a 15-minute break, use the restroom, get more food, whatever, that would be appropriate.
Dr. Mary, what did you call that again?
What you call
What?
a break? What you call a break?
Human element range extension.
Okay.
The acronym is HERE. So you put that on the door of the restroom. That is actually a copyright.
So you have kids that come in the lab.
Yeah, like during your house, the custom for land or higher roof house accident.
What?
NGSS, the 2 pages I sent you for the.
Yes, I did. I just haven't gotten to them.
No, they looked okay.
I haven't even. I really haven't gotten to them.
You got the email.
Yeah, I mean, I was thinking we wanted to do more than just the NGSS because you guys also added a whole bunch of material to the common files. The pre-assessment and post-assessment. There was a rubric for something, and yeah, I could look at it and discuss it. So why don't I look at it? Okay, so let's.
And they all like, it's funny because after the measurement, she goes, measurement was never this hard. But all they had to do was metric, and then
I'll be right
their
back.
weakest thing, they would measure the skin. And it would just be a cardboard, and they would measure the body, measure the fins, measure the air suit, and then we just put it together, cut it out, put it together. And it was literally we would race them. And they slide against the ground and have very little friction. So
Okay.
they just have to go 40 feet.
You see, you guys added.
They were just struggling. It was hilarious.
The internet in this room is ungodly slow.
Because I made them use all standards because everyone's
Okay, you guys added formative assessment examples, science notebook rubric, teacher, useful tabular. I haven't finished that. But also. You added the
Pre and post test.
pre and post assessments for the whole thing, and so in other words, the screenshot, if nothing else, the screenshots of this page probably need to be updated.
Okay.
And so you did add that, and that. Why does it think? Oh, I just have never been there, I guess. So, yeah. Besides the NGSS alignments, which are. Wait. Oh, I didn't put. Oh, reminder to self. I actually uploaded PDFs of the entire NGSS alignments, but didn't link to them. But the NGS alignments are in every zip file.
Yeah.
Okay.
All right. Well, I will work on that on Monday.
Okay.
Can I collect those for you when they're done?
Well,
I mean, if you want to wait, we can. That'll be easier. I didn't know they were doing right now. Is today, at any point in the day, are you, and I just can't remember, talking about the competition or giving them any, but today's more about the curriculum.
I covered that when you were downstairs looking for stray lambs.
Okay. And the stray lambs that I was looking for are the ones asking me the question, so they didn't hear it. But next week it's just more, all of it's about the curriculum. It's not about like the competition per se, right?
There's very little about the competition per se.
In either training day, right? Okay, that's what I thought.
But I did cover.
He asked me the question, so I said, "Let me make sure."
I did cover the email. I mean, the entry location.
Right.
And I said, I went through my speech about if you drop out, let me know.
Right. I think I came in on the tail end of that. So, okay, cool.
But that was basically all I said. We have a capstone when it is.
Right.
And I give more details on the practicalities next week, but even there, it's shrunk from 2 hours to about 5 minutes, so we can talk more about actually teaching the curriculum.
Teaching it, yeah. Okay. That's what I think.
Okay, well, I guess these guys are still working. As soon as you're done, wave your hand, and we'll reconvene.
if it's easier, I can have Laura send those through intercampus mail, and they can complete them during book breaks. Would that work better for you, so you can get back on track?
Do you think it would be a waste of time to? I did not know about this. It has to be sent out separately by Colleen.
Yeah, they all have individual links to their particular survey. That was the issue. I can see if Laura can have access to that, but at this point, we're
out of time. Or, I mean, if you send it out Monday and said, look, we've understood that we finally realized what the problem was. Please go. This is your personal link, but we are still giving these incentives, and we haven't done the drawing because we just realized why we weren't getting any responses.
Right. Let me brainstorm with her on Monday and see what we can come up with, and maybe I'll be in touch with you on Monday and let you know.
Okay. You don't have to just send it.
A couple of the teachers were just asking about the price, and then I said, well, your school's going to reimburse your rate. They're like, no. So if their school's not reimbursing them, can they get a different rate, or can they get a, hey, we're glad you're here for your service? I mean, I don't know. It's up to you. I just thought I'd ask.
You mean for this workshop? Or?
Yeah. Like their school won't reimburse, they don't have funding. It's up to you.
That's really hard because, you know,
If we get a
we're
scholarship,
losing money on the food as it is. I mean,
yeah.
it has to do with I have to try.
Can we let them pay 15 instead of 25?
Yeah, no,
Or no?
that's
We gotta keep it?
impossible to
Okay.
police.
Okay, that's fine.
And
They just asked me, so I said I would ask you.
yeah, no, it has to do with the rules. I mean, you know,
Okay.
we're not actually allowed to pay from most of our sources to people. We only have very limited fraction of the available funding sources
To go to food.
can cover the losses.
Okay. Gotcha.
So that's why
that's kind of where that goes.
we're really supposed to actually cover the food costs with the fee.
Okay, with the fee. Okay, that totally makes sense. Okay.
So I'm just trying to think to brainstorm how to do this, because if it's getting caught in spam filters and firewalls, that's a different issue altogether.
Well, no, if the issue really just is, I mean, okay, if the emails that Laura and I have been sending out all summer have contained a generic link that they couldn't get to their survey through, then
Do you think they might have given up on trying when Colleen sends it? That could also be true. Why don't I coordinate with Laura and Colleen on Monday, and we'll work at some sort of a plan to send out one last effort.
yeah, I mean,
I'll also bring these next Saturday morning.
the basic problem is that if only the individual emails from Colleen, they only got one of those.
No, they've gotten 3. She sent it
Oh.
at least 3 times, at least, I think 3
Okay,
or 4
but did she have the incentive message in there?
And the last one had the incentive, because that's when
Okay.
it was decided.
Well, they may have been clicking on Laura's because we didn't know we shouldn't be sending them.
Right. And I didn't know either. I mean, until I realized, and she mentioned to me that they all had individual separate links. Then it's like,
Okay.
oh, okay. Well, thank you for giving me
Okay.
a few minutes this morning. It looks like there's just 2 more left.
Okay, when you guys are done, well, actually, I should probably start. We have an awful lot to cover, so I'm going to chew on my buddy Rachel and my buddy Doug, who are the people who are responsible for this. I figured out why it didn't work when I said, oh, don't download the new version, because, of course, I was in the middle of a class, but I had to, because the part I'd downloaded wasn't compatible with the current interface. So this is the eyes on the solar system. Now, in our lesson 1, grade 6-8 lesson plan, we talk about using digital planetaria. Digital oraries are technically what you're using to actually illustrate the solar system and illustrate different views, because one of the biggest misconceptions, there are a bunch of misconceptions out there amongst the children about the solar system. One is the scale size. Another one, what was it, 3 years ago? The question that everybody got wrong on the 5th grade tax: what's at the center of the solar system? 70% of the children answered. How many of you know the answer to this question? It's Jupiter. Because the pictures in all the textbooks show this little arc of the sun off to one side, then the planets in order but not in spatial scale. In the middle of the picture is Jupiter. So the whole idea that the sun's at the middle of the solar system just never got through. So our lesson plan is based on using a digital orrery to illustrate that the sun is the other problem is that many children think that the orbits are very elongated ellipses. The Earth's orbit is actually nearly circular. It's only ellipsed by a little bit. By the way, when is the Earth closest to the sun? January 5th, which really means that the elongated orbit explanation of the seasons really doesn't work. But they take the elongated ellipse picture from side-on views in printed textbooks, and they don't recognize that these are side-on views. So, now, in lesson 1, we recommend, particularly for grade 6-8, we recommend that you do digital, you use a digital orrery to demonstrate the solar system in a way that gets past some of this. Oh, please. Stay where I put you. Okay. So this is eyes on. Oh, good. Oh, please, come on. I don't seem to be able to do full screen and keep it on this. So this, now we recommend several different choices of digital orrery, but this particular now, I definitely recommend that you play with the software before using it, but this script, which I don't think has sound, does give you a tour. This is Mars, and that's Phobos that we're looking at. Now the tools are all in here to construct a tour like this yourself, but why bother? They have neat tours. That they have pre-recorded for you. Now the thing that's particularly specific about Eyes on the Solar System is that it's designed to show where all the spacecraft are right now. So we're now showing 2 of the spacecraft around Mars. I'm fairly sure they're going to update this to include Maven as soon as Maven arrives. If they don't, Rachel's going to hear from me.
Are we the only nation that has satellites at Mars, or does it show other countries that?
That question has 2 answers. The answer is one of these orbiters is a European orbiter, and an Indian space agency spacecraft known for some unknown reason as MOM that stands for Mars Orbiting Mission, arrives, Maven arrives on Sunday. Mom's orbital insertion maneuver is the 25th, so that would be Thursday. So and there's a reason they're going together. That's the optimum time. So there are a variety of nations have sent spacecraft to Mars. Frankly, the Europeans and the Soviet Union have spent much more time and energy on Venus than the U.S. has. The outer planets are a largely American sphere of activity, although now Juno, the next American mission to Jupiter, is en route, but the next mission after that is called JUICE, and that will be a European Space Agency mission.
But we can't see those on this simulation.
I don't know. I'm going to let this this recording finish. This gives you some idea of what you can do with this tool. You can look down on the whole solar system. Well, this is actually, we're looking at the Saturn system. We put in the orbits. Let's see. I think it's replaying at this point. And these are tours of specific missions, other missions. Explore More takes you to a NASA webpage. Okay, the answer is yes. I can see from here because Rosetta is on this picture. Rosetta is a European Space Agency mission. And I'm not sure which one of these Mars missions that they're looking at is a but so this is the home page, and we can look at, okay, Rosetta is a European Space Agency mission. So this is past news. This isn't quite as current as you might like, but it can give you info. You can explore more. I mean, you can just look around. You can navigate. And so you can do a lot of things, and I advise you don't wing it. Take the time in class to don't take the time at home to prepare to use this tool. And you may need to get with your IT people to install it on school computers. This is actually an install tool. This is a real client-server tool. It's running interactively, talking to JPL right now. So the so you can, there is actually they have multimedia tours. You can change the speed, and you have tours and features. So here's one on, that's what I was really looking for. So now we're looking at, and I think it's Mars Express. That's the European spacecraft, to answer your question. So yes, it has European and other spacecraft. So this is actually real time. Okay. This is going to show you anyway, I'm going to speed it up. So you can speed it up and show things moving, and this seems to be set up to show Mars for quite some time. Okay, first time I looked at that, that's way in the past, so that's probably not something I want to spend any more time on. I am going to go back to my presentation. And I'm going to begin with a quick overview of what we know about Mars, because that's the real focus of today, Mars science. Now these are the Earth and Mars to scale. The Earth view shows Africa and Antarctica at the bottom. The water, ice, and clouds dominate the picture. You don't see any water on Mars, although you can actually see visible water on Mars in the form of ice. The polar caps, in southern summer, the southern polar cap is is water ice. In northern summers, ditto. Both of them in their own winters get covered with carbon dioxide ice. Mars is, about half the diameter of Earth. So you'd think, gee, it has, a quarter of the surface area. But the solid surface area is about the same as Earth, which means from a hard rock geologist viewpoint, there's an awful lot of geology out there to do. I'm trying to think. People actually use the word selenology to mean geology on the moon, but I've never heard them use Marsology. The day is almost the same as the Earth. Now, the guys at JPL who run the spacecraft on Mars, they tend to work in Mars days because, well, you can only drive around in daylight. And so they have these very strange work shifts. Most of the people who actually drive Mars rovers are little bitty people, or young people who don't have a life otherwise. Or they have their own social group. It's fascinating to sort of lurk and stalk on Twitter. Okay, there'll be a quiz at the end of the period. Take this down quickly. Actually, it's in your handouts. But the mean distance, the semi-major axis, is 1.5 the distance of the Earth, 1.5 astronomical units. It's actually not in the same orbital plane as the Earth quite, and somehow this table came out funny. You have to read the temperature table. Oops. Temperature table came out funny. Minimum is minus 125 Fahrenheit, 186 Kelvin. Mean is minus 51 Fahrenheit. And the max, 268 Kelvin, which is 23 Fahrenheit. But that only occurs in a few isolated places in deep canyons near the equator at noon in midsummer. I think one of the strangest episodes of this past year is the state senator in, Kentucky, who asserted that the temperature on Mars is the same as the temperature on the Earth. And I'm going, wait, what? And then got all upset when he was jumped all over by everybody and their brother. And the one thing, and this is actually apropos of being a good, effective teacher, and trust me on this, those of you who haven't been doing this very long, you will be caught making a factual error. You're never going to get all the facts right. And if one of your students says, I'm sorry, but Copernicus did consider epicycles, this is the nastiest one from my children's education. Your graceful exit is to assign a term paper. Okay, go to the library and document that for me. 5-page paper, please. First off, the students probably will, because they're motivated to prove you wrong. And secondly, you've got two things out of them. You've earned their respect by admitting you're wrong. And you've gotten them to hone their research skills, go read something, and write a paper. So you win. Couldn't persuade my son's teacher of that. And sitting right there in her room was a copy of Copernicus. And 82 pages were devoted to epicycles, and one of the kids went and got it and said, "Here." Wouldn't budge. Not effective. So if you are caught like that senator in Kentucky, totally being wrong on a basic fact. So general features: Mars is not very dense. It's actually iron poor. It has quite a lot of remaining water, but all of it's frozen in the soil and in the polar caps, and possibly in a deep subsoil layer. Mars has had some degree of active volcanism in the recent past. But it's otherwise been very, very tectonically inactive. Mars has a more eccentric orbit than the Sun. This is an actual depiction of Mars' orbit. You can see it's visibly elliptical, unlike the Earth's orbit, which really is very close to circular. Mars has two little tiny moons, Deimos and Phobos. They are both almost certainly captured asteroids, whereas the now this picture is really cool. I don't know if it was actually taken by some Mars orbiting spacecraft or whether this is an artist's conception, but the thing about the Earth's moon, we now believe that to be a secondary object created in the aftermath of one of the collisions that formed the Earth. The Earth was hit by a proto-Mars, and a good bit of the ejecta from that collision condensed in orbit to form the moon rather than eventually collapsing back onto the Earth. Mars moons are captured asteroids. And they're smaller than the minimum size required to force a body to become a sphere, which is somewhere is a radius somewhere around between 200 and 300 kilometers. Below that, the intrinsic strength of rock will support rather bizarre shapes. Above that, it's going to be forced into a sphere. Mars has had a very interesting climatic history. The Maven spacecraft is actually intended to elucidate the climatic history of Mars by measuring current loss rates of various volatiles. But 4 billion years ago, when Mars was young, it had enough atmosphere to produce enough surface pressure for liquid water to be in equilibrium. It was warm enough for water to be liquid because of the atmosphere. And over time, because it has relatively weak gravity, both the atmosphere, it has weak gravity and no magnetic field. The no magnetic field allows the solar wind to get down on top of the atmosphere and sweep. It's a steady loss mechanism. So over time, as the atmospheric pressure went down, the water ceased to, you reached a point where A, the water froze, and B, it sublimed. Once it's sublimed, solar ultraviolet breaks up the water molecule, and the hydrogen disappears. And the oxygen then goes into oxidizing all the rocks. Mars, we've now had enough orbiters around Mars for enough years that we have a very good idea of the topography of Mars. Mars has a in an ultimate triumph of zoning, Mars has a volcanoes district. That was a joke. But all the big volcanoes tend to be clustered in this one small quadrant of the surface of Mars. This is Olympus Mons and the other big volcanoes. The fact that the volcanoes have sat there, have grown enormous, and there are only a few of them, indicates that Mars has no continental drift, because the mantle plumes that produce these volcanoes stay in one place, and if the continents aren't moving over them, then the volcano just gets bigger and bigger and bigger and bigger. There have been, in the distant past, some very large impacts. This is the Hellas Basin. That's an impact basin. So it has both volcanic craters, the calderas of these volcanoes, and impact craters. And some of the older surface of Mars has a lot of impact craters. This is a unique feature that we don't really fully understand. Clearly it's associated with faulting of some sort, probably faulting produced by the rise of all these volcanoes. But this is the Valles Marineris. To give you some idea of the scale, this is longer than the United States is wide. It kind of totally dwarfs the Grand Canyon because its walls are literally kilometers tall. You can tell this color here is 4 kilometers below the mean. That's 4 kilometers above the mean. So you're looking at an 8-kilometer scarp from here to there. Much that dwarfs anything on Earth. So here are some names. This is Olympus Mons. This is the Tharsis Bulge. These 3 big volcanoes together here. And here's where some of the landers have occurred. Viking 1 on the Chrysae Planitia. Pathfinder near where the Valles Marineris lets out onto the Chrysae Planitia. Opportunity was here. Spirit was over here. And let's see if I can actually spot Gale Crater. On this scale, it's a little hard. Gale Crater, where Curiosity is I think it's that feature. It's one of these features in here. Maybe that one. The unique thing about Gale Crater is it has a stratified mountain in the middle. How can you get a stratified mountain in the middle of an impact crater without having geological processes that remove the crater? That's really, really strange. So here we have the 2 big impact basins, Hellas and Argyre. Okay. Now, one of the tools you're going to use in teaching our curriculum is Google Earth Mars. Now, I want to be clear that we're talking about Google Earth Mars rather than Google Mars. Google has made life confusing. What else is new? Let me go to Google Earth. Google has produced 2 Mars products. One is Google Mars. That was the first one. Google Mars is great except for one thing. It doesn't have anywhere near as many nice tours as Google Earth Mars. And it doesn't give you the latitude and longitude. What's up with that? I have no idea why they did that. Google Earth Mars gives you the latitude and longitude. Why is this important? Because when your kids pick a site for their mission in, I think it's lesson 8, one of the things they have to specify is exactly where are they going, even by latitude and longitude. So let me bring up Google Earth. You know, I had this all the way open. What the hell? Okay, there we go. Now, hopefully, this will let me do this and be nice about it. Okay, so I am now actually looking at Gale Crater. Okay. Now what I have done here is, what we recommend that you do is, there is a wealth of, I guess I want to close that. There are, in the layers, under the layers tab, there's a wealth of information about Mars. You can find all the rovers and landers, and you can also find a bunch of guided tours. And this is a good one, and I actually have it loaded here. Okay, so I'm going to play it.
Hey, Bill Nye, the science guy here from Google Earth's Mars 3D. In the 1900s, our ability to explore Mars via telescope from the Earth had reached its limits. And combined with our growing spacefaring capabilities, Mars became an excellent candidate for robotic exploration.
Is that loud enough?
Visits to Mars with spacecraft were only flyby visits by the Mariner 4, 6, and 7 spacecraft. Now, these quick passes, while spectacular, only allowed for a few limited in scope, low-resolution images to be taken, which really only showed plains and craters, kind of a moon-like view. we did the same thing with the Earth, we might have only gotten pictures of the ocean's surface or clouds and not even known there was any dry land. It wasn't until Mariner 9 went into Mars orbit in 1979 and started systematically mapping the planet that we really got a good sampling of the wide variety of Martian geology. Along with our orbital spacecraft, we also sent robotic explorers to the surface with mixed success. The Soviets were the first to attempt to land on the red planet with their spacecraft called Mars 2 and Mars 3, which arrived during the height of the 1971 dust storm. Mars 2 was lost, but Mars 3 might have made it safely to the surface. No intelligible signal was ever received. Mars 6 returned data as it descended through the atmosphere, but the signal was lost when the spacecraft was expected to land, indicating that there was probably a crash. The first successful landing was NASA's Viking Lander 1 in 1976. It touched down in Crisa Planitia, a vast flat desert whose initial soil analyses indicated that the soils were primarily volcanic, but there was evidence of salt and other minerals, indicating that water perhaps had once flowed across these plains. The Viking 1 and Viking 2 landers had an array of scientific instruments with which to sample their new home. Most talked about was the biology experiments. The Viking landers carried a small wet chemistry lab and an arm to deliver soil samples into each one. The experiments determined that scoop-accessible Martian soil was sterile, most likely due to ultraviolet radiation, but another part of the experiment detected some sort of chemical activity, which, while exciting, was just a chemical reaction that most researchers think had nothing to do with life or any living thing. 20 years later, NASA sent the Pathfinder lander to where Ares Vallis empties into Crisa Planitia. In addition to the medium-sized lander and its instruments, Pathfinder brought with it a kid's wagon-sized rover called Sojourner, which puttered around the lander, examining rocks with its instruments and learning things about what must have been the Ares Valley's flood. In 2003, NASA launched the Mars Exploration Rovers, the MERs, which later came to be called Spirit and Opportunity. They landed on Mars in January of 2004. Spirit was sent to the plains of Gusev Crater. Its first stop was the nearby Bonneville Crater, but after that it made treks for the Columbia Hills off in the distance. The Columbia Hills are named after the Columbia Space Shuttle, which crashed in 2003. Almost 6 months from the time of its landing, Spirit got to the foothills and started switchbacking its way to the top of Husband Hill. Husband was one of the astronauts on the Columbia Shuttle. It took Spirit a whole year to climb to the summit. But once there, it had a marvelous view, and it got a good look at the feature named Home Plate and started heading toward it. Spirit spent a lot of time here exploring the area and characterizing the minerals and stratigraphy exposed on Home Plate. The Spirit and Opportunity rovers are identical twins, or nearly identical, and they're equipped with 9 cameras. They have 2 HAZ cams, or hazard cameras, looking forward, 2 HAZ cams looking back, 2 nav cams, navigation cameras. They're mounted up on the mast, which is as tall as a 10-year-old's eye. But what I mean is as high as a 10-year-old's eye. Then up there also are the 2 pan cameras, panoramic cameras. They're for the panoramic color and science on the mast. And there's one microscopic imager out on the rover's arm. Now the microscopic imager is like a hand lens that a geologist might carry. That arm also has some spectrometers for measuring different aspects of the rocks, and the RAT, the rock abrasion tool for grinding and brushing rocks off so you can get through the rime of weathering, provide a clean surface for the instruments and the geologists here on Earth to have a look at. On the rover's back, nestled amongst the solar panels are various antennae, and on the aft solar panel, there's a curious little thing called the Mars dial. The other Mars exploration rover, Opportunity, landed in Meridiani Plana, almost in the middle of a small crater, an interplanetary hole-in-one. Its first stop was the medium-sized Endurance crater, which it drove into and examined fine layers exposed there. It then started driving south, past its own heat shield from its own descent module, and even got stuck in some deep sand quite a while before it eventually reached Victoria Crater with its magnificent exposures of sandstone. Opportunity then circumnavigated a good distance around the north rim before coming back around to the west, driving down into Duck Bay, where it examined the layers on the side of Cape Verde. After that, it drove around to the southwest of the crater and started looking south. Opportunity's next big destination is the much larger Endeavour crater. It's 14 kilometers away, 8 miles or so. In Opportunity's 5 Earth years of operation, it has only gone about 6 kilometers, 4 miles from where it landed. So it may take some time to make it to Endeavour crater. The most recent spacecraft to land on Mars, the Phoenix lander, did so far, far to the north of the other rim. The HiRISE instrument, a high-resolution camera aboard the Mars Reconnaissance Orbiter, captured this image as Phoenix was descending on its parachute. Although it looks like Phoenix landed inside the Heimdall crater, the orbiter was actually very far away and took the image at an oblique angle, creating this optical illusion. In this image, Phoenix is about 20 kilometers in front of the crater. The cutout at the left shows a blown-up version of Phoenix hanging from its parachute during its descent. Phoenix actually landed on the plains well outside of the Heimdall crater. Phoenix landed so far north at a position similar to the high Arctic on the Earth that the team knew the spacecraft wouldn't last very long. It could only operate until the Martian autumn or fall, as the sun would dip down low on the horizon. The solar panels would not be able to recharge the batteries, and then it would be coated with carbon dioxide frost, a blanket of dry ice, maybe a meter or even more thick on top of the spacecraft. In its short but productive life, it accomplished a great deal. It dug trenches, probed permafrost layers. It's the first spacecraft to touch frozen water on the surface of Mars. Phoenix made many other measurements that scientists are going to be working on for a long time to completely understand.
Okay, that's the full tour. Unfortunately, as you can probably tell, it's about 5 years out of date, because in the interim since then, Spirit has stuck and died. It got stuck in the sand, couldn't get out, and was not oriented to survive the winter. The solar panels weren't in a place where the wind would blow them clean from sandstorms, and where they were tilted toward the sun to get maximum sunlight during the coldest part of the winter. So the batteries froze. Opportunity is still going strong. Its biggest threat is NASA has a budget issue in planetary science, and they almost this year had to choose. At one point, it looked like they were going to have to cancel, pick 2 of 3, Cassini, continuing operations, Opportunity, or Curiosity. And guess what? Curiosity came in last in the evaluation, mostly because the team didn't take the evaluation seriously. They thought they were too new to fail. But Congress intervened and provided some additional funds. But NASA is building spacecraft that are too good. Both Cassini and Opportunity have been running for 10 years. They were budgeted for a year or 2. Because if you spend $1.5 billion to send them there, you probably want to keep working. Now, Opportunity has been to Endeavour Crater, examined it, gone down in it, taken a whole bunch of pictures and rock samples, done its science thing, and has come back out and has gone on to, oh gosh, what's the name of the crater? There's an even bigger crater south of Endeavour that they're working on. Um, no, they've gotten to Endeavour and they're working on Endeavour. It was Victoria Crater that they stopped at along the way. So they've been to Victoria Crater and to Endeavour Crater. They actually at Endeavour Crater now, slowly working their way around the rim. And the rim, it's kind of like if you have a layer cake and then you drop a baseball in it, the layers expand upward and you sort of see the layers. So the edges are this fascinating set of exposure to geological history on Mars. So Endeavour is really doing an awful lot of really good science. And I'm not going to spend any more time on Google Earth except to point out one thing. Oh, Lord. I'm going to exit this tour. So I've exited the tour. I think I've exited the tour. Yeah, this button here. You actually are going to start in actual Google Earth. And don't go to Google Mars. Go to Google Earth and then get to Mars using this tab that I'm pointing at right now, because it's a far better tool. Google Mars is still there, but it's a beta version. Okay, so let's see. So what's it like on Mars? Carl Sagan, the guy who first broadcast the Cosmos series, one of the great science educators of the last generation, he was my Astro 1 professor, actually had an experiment on the Viking landers to look for large objects. He called it his giraffe-o-meter. And what he did was he would take the cameras, and instead of, those cameras worked in a funky way. They took a strip, recorded the strip, and telemetered it, then they rotated it. So they were actually strip cams. What Carl did was he would run the strip cam pointing in one direction and look for objects moving through the strip. Giraffe walking by. He didn't see anything, but he actually got funded to do that. There is, as far as we can tell, no life. The air pressure is about 1% the surface pressure here on Earth. Consequently, the sunlight is intense, and the particle radiation reaching the surface is pretty strong, cosmic rays. Yeah, it's dry. The dry valleys in Antarctica might be equivalently dry, but nowhere else. And like I said, the mean temperature is minus 53 Fahrenheit, which is actually, curiously, equal to the mean temperature at South Pole, the annual mean temperature. So we have reasonable analogs to a Mars expedition for everything but the air pressure. Mars' atmosphere is composed almost entirely of water ice, of carbon dioxide. There's some water ice clouds, and there are carbon dioxide ice clouds. The surface temperature in Kelvin is about 250. And that has a very large range of variation. The stratospheric temperature, the stratospheric temperature on the Earth can be as low as 200 if you're in the right place. It's 100 degrees, nearly 100 degrees colder in the stratosphere of Mars. But you can actually see morning fog in certain craters in photographs. That's ice fog. For those of you who've ever lived in Fairbanks, you know about ice fog. The thin atmosphere is still enough to support parachutes and stop spacecraft, which is good. It'd be much harder to land on if we didn't. This picture is a picture of the Tharsis Bulge. This is a color image mosaic obtained by the Mars Orbiter camera on the Mars Global Surveyor spacecraft. Olympus Mons. That's Olympus Mons. And this is Ascraeus, Pavonis, and Arcia, the volcanoes. The upwelling air as it passes over Mars is very windy, and the upwelling air as the air passes over these volcanoes, these features here are water ice clouds downwind of the volcanoes. The air goes up. It's just like what happens on the Front Range in Colorado. You have air coming in from California, goes up over the mountains, and as it comes off the top on the downwind side, you get these lenticular clouds. That's what's going on here. This film was taken by Spirit at Gusev crater. Those are dust devil tornadoes. And curiously, those things are electrified. They produce lightning strikes, which is really quite amazing. Because we thought the discovery of lightning on Jupiter and on Mars has really been an interesting discovery, because we thought lightning required liquid water. Doesn't seem to. Now, this picture here, these are pictures from the Hubble Space Telescope, and they're taken, this is in June and that's in September. What you're seeing is notice that the surface features have disappeared. That's Hellas there. Surface features are gone. This is a global dust storm. They occur every so often. When Mariner 9 first arrived at Mars as the first orbital mission, there was a global dust storm going on about 1971. It took several months for it to decay. The experimenters on Mariner 9 were just beside themselves with frustration. This picture was taken in 2005, and it shows a very interesting view of a region near the Martian North Pole. And you can see, this is a close-up view of a bigger image. You can see sand dunes, ice, a weathered escarpment that's still in the process of eroding. You can see sort of contemporary landslides, more ice. Very interesting, showing a lot of these cliffs are about 2 kilometers high, and the material in here may well be volcanic ash. So there's all sorts of interesting science in this one picture. Now this picture was taken by Opportunity in Endurance Crater in 2004. And the floor of Endurance Crater was covered with dunes. This is a close-up view of the big Barkhans. Now, hey, this view, that look a little, no, we're Houstonians. That doesn't look familiar. This is something known to, quaintly called by the natives in places like Colorado, snow. I'm not sure which spacecraft took that picture, but wintertime picture from a rover showing snow. And this is the northern polar cap in summer, and this is all water ice. So the difference between Earth and Mars is graphically illustrated here. There's Mars, there's the Earth. Mars just doesn't have any liquid water. It does have ginormous volcanoes. Now, I guess if you have kids who haven't traveled much, if your kids happen to have taken the Great American Vacation, you know, pile everybody in the car, drive to Seattle and back, get home and get a divorce, right? Actually, then the divorce is the parents divorcing the kids. They may have actually some concept of how big Arizona is. This volcano, it's 22 miles high, and it's the size of Arizona. Well, okay, astronomers tend to gravitate to Hawaii because telescopes. There are telescopes on Mauna Loa, and there are telescopes on Haleakala. So an astronomer made this picture, and he compared the Hawaiian Islands, which are each giant volcanoes. The Big Island itself is the biggest volcano on Earth, and it's dwarfed by Olympus Mons. Oh, here's my illustration. Olympus Mons and, oh yeah, Arizona. Arizona is a big place. My wife and I drove across it this summer. We made the mistake of planning to drive from just about here to just about there in one day. That's a 12-hour drive. Whimper. So more on Olympus Mons. It's 3 times as high as Mount Everest is above the sea. And the escarpment, the cliff here, 4 miles or 20,000 feet. For those of you who have been to, say, well, the most Pikes Peak rising out of the Rockies, that's half that height. Half the height of Pikes Peak. If you've been to the Sierras and seen Mount Whitney rising above Mono Lake, 2/3, that's a little more than half that height. If you've seen Denali from, say, Fairbanks or from the viewing point in the park, you're looking at most of the height of just the escarpment, the 4-mile escarpment. Remember, this whole puppy is 22 miles high. Imagine the ski resort. The other great feature on Mars is the Valles Marineris. I've talked about it. It's a trough 2,500 miles long and 6 miles deep. I think I said that, 8 kilometers. To scale, the Grand Canyon. This is a detail of this region, and this shows details of some of these other regions. Just amazing. Parts of the Martian surface are heavily cratered, and parts are more recent. This is Hellas again, or is it? No, it's Argyre. Yeah, it's Argyre. It's 1,850 kilometers across and 5 kilometers deep. It occurred somewhere around 4 billion years ago. At the same time, the Mars shows clear evidence of sedimentary rock formation because you can see clear stratigraphy. That only happens if you have oceans or repeated layers of volcanism. This is the Cape York area of Victoria crater. No, not the Cape York. Cape Esperance? Well, something like that. The reason Mars is really interesting, first off, is as much geology there as on the Earth because the solid surfaces are the same area. But you know, the Moon, after there was a period called the late great bombardment, or the late high intensity bombardment. The Moon formed maybe 4.5, 4.6 billion years ago, but 3.8 to 4 billion years ago, there was this late heavy bombardment of the Moon and all of the objects in the inner system by meteoritic material, asteroid material, and the Moon dates from that era. Mars seems to be in between. There's still quite a lot of, Argyre, for instance, occurred about there. Hellas, probably about the same time. But there's been quite a bit of resurfacing. You don't see many impact craters in the northern hemisphere. Hemispherically asymmetric resurfacing, which is very curious. But so Mars is intermediate in age. The Earth has very few craters than we can detect. So 4.5 billion years ago, Mars was warm and wet. These are artists' conceptions. This is what Mars might have looked like maybe 3.5 billion years ago. Some of the craters have lakes and rivers, but they're still shown as bare rock. There's no evidence that life formed there. The polar caps are very seasonal. In the winter, the polar caps acquire a coating of carbon dioxide. The southern winter is much deeper and more intense than the northern winter, and the whole atmosphere loses pressure in southern winter because so much carbon dioxide freezes out. Now, there's a lot of evidence that there was water on Mars. Even before we put rovers down to look for it, this looks like the region of the Great Flood in northeast Washington State. The so-called channeled scablands. These are clearly flow features eroded around these crater walls. This looks like a delta, this water flowing in here and ponding in some fashion. And these look very much like drainage features. The meandering is characteristic of water-based erosion. One of the real excitements of this year in planetary science, they have seen meandering gullies on Vesta. Vesta? 400 kilometers across, tiny asteroid, Vesta, had liquid water at one point? That's amazing. So how can we tell if liquid water has flown across the surface? Well, with the possibility of water, we have the possibility of life. And people are looking hard for the evidence. Unfortunately, this has brought what we would call the scientific component of the conspiracy theory crowd out of the woodwork. This is an early photograph, Mariner 9, or one of the earlier orbiters, of what's called the face on Mars. It's not. The Mars Express has a camera specifically designed to take stereoscopic pictures that's high resolution. Several of the subsequent orbiters have high resolution, and with the help of computers, you can actually visualize the data produced by the stereoscopic imagers and see that this is nothing more than the kind of mountain you'd see in the Basin and Range province in Nevada. You see mountains like this all over Wyoming and Nevada. It's just a mountain. The Viking landers have looked for a bunch of stuff. It's really interesting. The Viking landers had a pre-flight protocol. What do we have to see to say that we've seen life? It actually passed. And they chickened out. They said, wait, no. And the subsequent landers have checked on the Viking landers and have concluded that, yeah, the wait, no was right. That what we had was a very, very, very oxidizing soil. There has been this one meteorite that is, where they're fairly certain, was blown off the surface of Mars, landed in Antarctica, and it has these little globules in it that are very high in carbon that look a whole lot like well, I know this is actually, I think, this is another image of what's found inside this rock. These look like fossil bacteria. Now, I think consensus now is that's not what was found, but there's still a strong body of opinion. Yes, it was, and that's part of what's motivating This is the meteorite, Allen Hills, 84. AHS stands for Allen Hills, ALH, Allen Hills, 84001.0. So it was the first meteorite found in the 84 expedition to the Allen Hills in East Antarctica. They're arguing over whether or not the organic material that are found was contamination from the Earth, and they point out that chemical processes could produce features like that. So the conservative view is this is not yet conclusive evidence of life having existed. Okay. I'm going to introduce you to one more tool, and then I think we'll break for lunch because the next thing after this tool is an activity. Okay? I've interspersed this with activities at some length, but this tool, worldwidetelescope.org. And Worldwide Telescope is high-end software, meaning it takes a lot of computer resources. It's free. I'm afraid Microsoft cannot actually reduce the price below that. It is available from Microsoft Research, and it actually, in principle, provides access to every spacecraft and telescope image ever taken. It's intended to be a professional tool. It isn't actually intended for home or classroom use. They discovered that it might actually be usable in home and classroom, and one of the very first scripts they got after they released it was from a first grade boy who did this really cool script. Worldwide Telescope actually has Worldwide Telescope Mars. Now, I tried to start it yesterday, and I had to reload it because it'd been upgraded. So let me see. If it will actually start for me today. And if it doesn't start right away, I'll let it run for a bit, and we can all have lunch while it chews on it. I thought I started it yesterday, but it isn't popping up on my machine. Okay, here we go. You know, this puppy's going to be slow. Why don't we break for lunch? I'm kind of a little frustrated because I actually loaded all these programs yesterday, and when I turned my machine on today, 2 of the 3 had disappeared. It's like,
It's pretty good because you get to know it well, I do about 7. This is a lot. Yeah, if you represent it, it's very easy.
and I think I'm also going